All right, today we're doing lesson 6.3 and we are dividing polynomials. We're going to start out with a review of just reducing some fractions when we have a monomial divided by a monomial. And if you want to take a quick minute to review your terms, this is a fifth degree, so we would call this a quintic monomial. We would call this a cubic monomial if we want to remember our names by degrees and number of terms. So the first thing I want to do is I want to look and find the GCF that I can take out of both of these. 24 and 18, my GCF would be 6. So I'm going to divide by 6 and I'll get a 4 and I'll get a 3 down here. I'll rebuild my fraction to 4 over 3. And then I want to knock out some of these z's. So we're going to go back to our power properties. A to the m divided by a to the n. We keep the base and we subtract the powers. Now one of the things we've done is we like to look and see who has more z's. And so I'm going to knock 3 out of the bottom and leave 2 of them in the top. So there's my final simplified fraction, 4z to the second all over 3. All right, come over to this one. We have more variables, but we're still going to reduce by 2. So divide by 2, I get a 4 and a 1. And then I have x to the third, x to the first, so that cancels out, leaves me 2 x's up top. And cancel the y, that leaves me 3 y's in the top. So I can leave this over 1 or simply have it as 4x squared y to the third. And then I have this next one that's a plus b all over c. If I look at this, there's nothing I can do. If I want to reduce it, I have to be able to take something out of all 3 terms. So I would leave this form alone, but it can be written with the common denominator being broken up as a over c plus b over c. And then if I can reduce the parts, I would. All right, so going with that example, if I have something like a plus c over c, one of the biggest mistakes we get is that people want to wipe out these c's. If I want to cancel, I have to be able to take it out of 1, 2, 3 terms. I can only take it out of these 2, so this cannot be reduced. So this would be my simplified answer, but another form of that would be a over c plus 1. Where did that 1 come from? If I take a over c plus c over c, the a over c stays, the c over c reduces to a 1. So I should be comfortable knowing that this answer is equivalent to this. Easy way to look at it, cover this up, I have a over c, cover this up, the c over c becomes a 1. This is a common denominator, so they both have it. If I try to wipe it out, the a loses its denominator. All right, our next couple examples, we have more than a monomial divided by a monomial. In this one, we have a 6th degree binomial divided by a monomial. So if you notice in these examples, they are all divided by 1 term, whether it's written as a fraction or we have a division sign divided by the negative 5x to the 5th. They're all divided by 1 term. So I want to remind you that when I'm dividing by a monomial, when dividing by a monomial, each term can be divided by the GCF. Each term can be divided by the GCF. Now, there's more than one way to do these problems. You'll have some people will tell you to factor the top and then cancel out the common factors, something we'll do in later chapters. The other way that I'm just going to do is I'm going to look at all 3, and if I can reduce all 3, I will. So what do all 3 of these terms have in common? Well, I can divide everything by a 3 and an x to the third. So even though it's the GCF, I have to look at the smallest number and I have to look at the smallest power because it has to come out of everything. So I'm dividing everything here by a 3x to the third. So divide by 3, I'm going to have a 5, knock out 3 of the x's, x to the third. Divide by 3, I get a negative 2, and my x to the third's gone. Divide by 3, I get a negative 1, and I have x to the third left. So this answer I'm fine with. You'll see some textbooks and worksheets, they won't leave a negative, so sometimes you divide by a negative 3. If I would divide by a negative, all of my signs would be the opposite, because everything from the beginning would change. So either of these answers are acceptable answers. All right, in the next example, we have 1, 2, 3, 4 terms. And if you notice, they all divide by this 3xy. So when I go to do this, one of the mistakes that we see is people want to cancel the 3xy with that, and that's it. But don't each of these terms get divided by 3xy. So I cannot just come in and cancel these. So divide each piece by 3. I'll get a 3. And then one of the x's cancels and one of the y's. So everything's being divided by a 3x and a y. So that'd be 3x to the second, y to the third. Divide by 3, I get a positive 5, but just a y. Cancel out an x and a y. Plus 1. 3xy divided by 3xy is 1. That 1 has to be there. Okay? And then if you want, you could write all divided by 1, because 3xy divided by itself is a 1 down here. This 1 has to be here. Divided by 1 doesn't have to be shown. All right, let's go ahead and look at this one. Each of these terms can be divided by a 5. I would like to divide out a negative 5 and the x to the 4th. So everything is going to divide by a negative 5 x to the 4th. All right, so when we divide by negative, we change our sign, so that becomes a positive 3. X squared is left over. A negative 5 x to the 1st divided by a negative 5 is a positive 4, but my x is gone. And then when I divide out the denominator, I'm left with a positive x. So this is an answer that I'm fine with. Someone else might have divided by positive 5, so all the signs will be the opposite. Another version of this answer could be 3x minus 5 plus 4 over x. So where did I get that from? If I take this and I break it up, 3x squared over x, this cancels out and leaves me 3x. The middle term is minus 5x over x. This cancels out and leaves me minus 5. And my last term is 4 over x, and I can't reduce it. I like this answer. This is what I'm comfortable with. But you might see this answer in a textbook or worksheet, and we want to know that that's equivalent. We are going to start the process of dividing more than a monomial, dividing by more than a monomial. So we want to go back and practice some quick longhand division from elementary school. So the 579 is considered my dividend. Just like stocks, it's being divided up. The 16 is my divisor. An employer employs, a divisor divides. And the answer to a division problem is called a quotient. So my dividend, the first term, goes under my division symbol of 579 is being divided up by 16. And when we do addition and subtraction, multiplication, we start at the right side and we move to the left. But when we do longhand division, we start at the left and move over. So first I'm going to look and see, does 16 go into 5? And it does not. So I leave a 0 there or a place there, and I look and see, does 16 go into 57? And it does. It goes in evenly 3 times. And then I take that 3 times 16, and I get 48. So how many times does 16 go into 57 evenly? 3 times. Take my 3 times 16, I get 48. And at this point, since I'm dividing, I subtract. And so I'm going to do a little borrowing, and I get a remainder of 9. As long as my remainder is less than my divisor, I've gone as big as I can. And then I bring down the 9. And I start again. How many times does 16 go into 99? So I might have to play with these numbers a little bit. It's a 6. So 6 times 16 ends up giving me 96. Again, we subtract to see what's left over. And I'm done because I have no number to bring down. So when you were little, you'd write at this time an R3, and you would have 36 remainder 3. Then you would start talking more about fractions. So you would have 36 and then 3 parts of 16, because if we kept dividing, we would take 3 divided by 16. Another year in elementary school, you'd put a decimal here and you would start dropping zeros and get the decimal. So we are going to stick with mixed numbers. All right, same idea. 121 is being divided by 4. So 121 is being divided by 4. So the first thing we want to look at and see, how many times does 4 go into 1? 0 times. How many times does 4 go into 12? 3 times. We take 3 times 4, we get our 12. We go to subtract, we have nothing left over, and we drop the next term as 1. How many times does 4 go into 1? 0 times. A lot of people want to jump in and say it's 3 remainder 1. It's 30 remainder 1. This would be 30 with the remainder of 1. but I'm looking at it as 1 would still be divided by 4. So I have 30 whole units and 1 part of 4. And if you take a minute and think about it, 30 times 4 is 120 plus the 1 extra piece. All right, so that's a quick review of longhand division, so we can work on a more abstract use of longhand division in polynomials. Okay, there's a couple rules here. So we have this first example here. Okay, so the first thing we want to do is we want to make sure that our dividend is in standard form, highest power to lowest power. So we want to go in descending order, and if we're missing anything, so standard form, and anything that's missing we want to include with a coefficient of 0. So if you look, I have a power of 3, a power of 2, but I don't have x to the first. That means I'm missing it. So I'm going to put in an extra 0x. That's going to be a placeholder. So when I go to write this, it's going to be 3x to the third plus 4x squared plus 0x. So make a little note that that is a placeholder. And a lot of people think they don't need the placeholder, but you do, because as you do the division, everyone needs a row. Even if it didn't start in the problem, it will come up later. And then we have our constant of 10. So here is our divisor or dividend being divided by x minus 2. And we also need this to be in standard form, and you might need a placeholder. All right, now that we have that, we're going to set it up just like we would regular longhand division. And we don't want to scrunch it up. We want to make sure that we have it neatly written out so we don't lose numbers. So I'm just recopying this down to use, and I'm dividing by x minus 2. So this is a little more abstract, but it follows the rules we've been doing. All right, so how do I start? Well, a lot like the longhand division, I want to make this first term look like this first term. And then we're going to bring everything else back in. So x times what gives me 3x to the third? A positive 3x squared. I want to take this first term times something to get 3x to the third. The other way you can look at it is take 3x to the third, divide it by x. I get 3x squared. So make the first term look like the first term. Then, just like before, I multiply this, but now I distribute to both. So I take my term that I picked times x, and I get a 3x to the third. And then 3x squared times negative 2 is negative 6x squared. So I force my first term to be what I want it to be, and then the second term falls out. And just like before, at this point in division, we subtract. And one of the things we want to be careful with is when we subtract, we want to distribute this sign just like we did with subtraction of polynomials. So I want to do addition of the opposite. So if you're just using a pencil, maybe make it a darker sign so you can see that you changed it. The first one should always cancel because we made it the same and then we subtracted it out. And the second one, we just add up whatever's left, which is 10x squared. And just like before, drop the next term of plus 0x. Once you get this pattern down, that is what you're following. So I start again. How do I make this x look like 10x squared? X times what is 10x squared? A positive 10x. If this was a negative number, that would be a negative up there. So take your 10x and distribute it. 10x squared, 10x times negative 2 is negative 20x. That's why we need that placeholder. So we had a place for this x when we got there. Okay, just like regular division, I come in and I subtract to find the difference. What I want to be careful about is not losing my signs. Now that I've changed my signs and I'm sure that that cancels out, I bring down my leftover of 20x and I drop the next term of plus 10. And I start the pattern again. How do I make my first term that I'm focusing on look like this first term? X times positive 20. So I'm building my answer as a polynomial by adding and subtracting the terms. 20 times x is 20x. 20 times negative 2 is negative 40. I'm going to come in and subtract. And again, this is one of the big places people make a sign mistake where at the end they just want to hurry up. We want to make sure that we still take the minute to change our signs. This cancels, and this leaves me a remainder of 50. Now, a couple ways I know I'm done. I have no terms to drop down. I cannot make x into a 50 by multiplying. So that 50 is my remainder, and the way I'm going to show my remainder is I'm going to add it on. I'm going to add on plus 50 divided by my divisor of x minus 2. What is above my division symbol is my final answer. So down here we have a spot that says write the final answer, and my final answer for this problem is 3x squared plus 10x plus 20 plus a remainder of 50 parts of x minus 2. Now, if we took the time to do this, we could take the x minus 2 times our answer, multiply all that out, longhand multiplication there, and then add in an extra 50 at the end, and we would get back to where we started. All right, we have another example here. The same idea. We want to make sure that our dividend is in standard form, and if we need placeholders, we have them. I see a power of 2, 1, and a 0, so we are in standard form. So go ahead and set your problem up. Make sure you have room. 15x squared plus 8x minus 12, and I'm dividing by 3x plus 1. All right, so we are going to start again by making the first term 3x into a 15x squared. So I could look at it like 15x squared divided by 3x gives me a 5x, or 3x times what gives me 15x squared. All right, now that I've decided what's going to make this come together, I take it and I distribute it. That's how I bring in the whole binomial. So I look at the first term and then I bring in the binomial. So 5x times 3x, there's our 15x squared we were going for. 5x times 1 is a positive 5x. So at this point we come back in and we subtract. I want to remember the parentheses are here because everything's being subtracted. It's really important that we change the sign so we don't forget when we get over to the 5. All right, this should always cancel because that's what we were going for at the beginning. 8x minus 5x is 3x, and then I am left with what's coming down, which is a negative 12. Okay, I'm going to start again, and I'm going to take 3x times what to get 3x? Just a 1, so plus 1. Take 1 times 3x, that gives me 3x. 1 times 1 is a positive 1, and I come through and I subtract again. We don't want to forget to change our signs out. And now this cancels, and I'm left with the remainder of negative 13. There are no other terms to bring down. I cannot turn a 3x into a negative 13 with multiplication. And so I have a remainder that I'm going to add on as negative 13 over 3x plus 1. Some people choose to subtract because it's a negative number, and that is okay. You have to watch if you have more than one term in your numerator. So my rule of thumb is just add on the negative. Your final answer is 5x plus 1 plus a remainder of negative 13 over 3x plus 1. All right, we have one more example where we're going to divide. And so we want to make sure again that this is in standard form, and I can see that I'm missing a y to the first, so I want to make sure I use a placeholder. So I'm going to start out by putting my dividend underneath my division symbol. So I have a positive 2y to the third, a negative y squared. I need a placeholder for 0y. Make sure you have a 0 because if you put a y that means you have 1. And then we have our constant of 25. Next thing I'm going to do is put my divisor out here, and then we'll start dividing. First step again, it might help you to highlight this. How do I make that first term look like the first term? I'm going to multiply by 2y squared. To bring in the binomial, we're going to distribute, and that would give me 2y to the third minus 6y squared. We're going to come in and subtract. Again, we're subtracting the whole binomial, so it's important to change our signs. And once we do that, the first term should always cancel, and we bring down that we have a remainder of 5y squared, and then we bring down our placeholder of plus 0y. we are going to start again. How do I make my first term into a 5y squared? I'm going to multiply by a positive 5y. 5y times y squared is going to give me a positive 5y squared. 5y times negative 3 is going to be a negative 15y. We're going to come in and subtract. Again, that comes out and it changes our signs. This is going to cancel out. It brings down a positive 15y, and the next term we bring down is positive 25. And at this point, we are going to start again. How do I make this first term y look like this first term? I'm going to multiply by a positive 15. I've already got the y, so I just need the 15 times y to come back to be 15y. 15 times negative 3 is a negative 45. Again, I come in and I subtract. This is where people mess up because they want to just jump in and cancel, but we want to make sure that we change these signs so we don't lose that last sign. This should cancel. We come down and we end up with a positive 70. There is no way to make a y into a 70. There is no extra number to bring down. So 70 is my remainder. So I'm going to go ahead and add on 70 parts of y minus 3. So the final answer is 2y squared plus 5y plus 15 and a remainder of 70 parts of y minus 3. There are other ways to do the longhand division. There's a shortcut. It's called synthetic division. Synthetic division is a nice shortcut, but it only works with binomials. When you're dividing by a binomial, it only works when your first term has a coefficient of 1, or you have to divide that out. So longhand division will work with any of these. Synthetic division is a nice option, and I will have a lesson on that. The other thing that you want to remember is going back to the beginning. If I'm dividing by a binomial, I'm using the longhand division. But if I'm dividing by a monomial, like these 3 examples here, then I want to go ahead and divide by taking out the GCF.